Hi everyone. In today's video, we're going to be using a Raspberry Pi to gather some temperature data from there, and then using MQTT, send that data to our Weintek HMI. Weintek HMIs come with MQTT.
Quick pause. Just for clarification, most Weintek HMIs support MQTT. Therefore, we're going to set up ours as a subscriber to the Raspberry Pi.
So we're going to set up a server on there, use Mosquito as a broker within our Raspberry Pi, and transmit that data to our HMI. Node-RED is going to be used to gather all that flow and make sure all of it's running smoothly. So let's get started. On the Pi, I'm running Mosquito as the MQTT broker and Node-RED as the low-code runtime. Some prerequisites for this video is that you need to have Node-RED installed, which is available on their website. You'll also need an MQTT broker like Mosquito here to send your payloads. With Node-RED open to a local web page, I start with the temperature node for the DS18B20. To get this node, I'm using the pre-built-in DS18B20 node that you can add to your palette within Node-RED. This node auto-discovers the sensor ID. You'll see that it starts with 28-5C6 and so on. I can adjust the read interval, give it a name, but for this demo, I'm just going to leave it as a default. That node gives me a live temperature value in the message.payload at the interval I set. We're going to see this value in our debug node later on. Next, I have a function node called createMessage, and what this function does is that it gets my message.payload in the correct format. And then after the payload is in the correct format, I'm returning the message. So that's essentially what this function does. I also attached a debug node, which is wired to the function node so that I can see the outgoing message. When I let it run, I can watch the values rise and fall over time. This makes it easy to confirm that the number is changing before I actually publish anything. Moving on to the MQTT broker node. This is the MQTT out. One of the most important things is this server IP address. And so this is the IP address of my Raspberry Pi. And I set this to the default port of 1883. And for my protocol, I am using v5 for the latest, but 3.1 is also supported. And then last thing is the topic for this is set at Weintek/data1. And then after this, I just hit deploy. On the EB Pro side, I go to the IoT/Energy tab and go to MQTT. Here, I can enable the MQTT server. And then I start by matching the protocol version, setting the broker IP address, which is the IP address of the Pi, the port to 1883, just like I did back in Node-RED. I can also enable status addresses. That way I can see if the client is connected, disconnected, or if there's an error, and this can be held within that LW0 address. For the incoming data, I add a MQTT subscriber. The topic for this is going to be that Weintek/data1, which was the same thing on the Node-RED side. For my content format, I have chosen JSON Advanced. In the template, I map the JSON value to LW10. I use the preview in the JSON Advanced dialog to confirm that the structure looks like that value followed by a string, and then I write the template. This allows me to ensure that the structure is correct on both sides of the MQTT communications. Lastly, for my object setup, I have a LW0 numeric object that's addressed to the LW0 to get the error codes out, and then LW10 holds the string. And so after we do an offline simulation to kind of see what it looks like, we'll see the message.payload, which holds the temperature values. So as you can see, it gets that 2, which means the connection is stable. And then we get our 23.375 out from our temperature node. And yeah, that's basically how we do our connection. If you guys have any questions, please leave them in the comments below. And that is it for this tutorial. Thank you.